Okay, here's your Unit 9 review video. Now we want to look and see whether or not each thing is a function. And for each function, we want to tell what the domain and range is. So for A here, we've got a set of ordered pairs that will represent a function or not. But if we look, we have an x2, 4, 6. None of those x's repeat, and none repeated x's have different y values. So each x value has its own unique y value. So we would say that yes, this is a function. Its domain is the list or set of x values, in this case 2, 4, 6, 8. Okay? And our range would be the set of y values, or 5, 6, 7, 8. Then for B, we look and we see that 1 happens twice, and it has different y values each time. So we'd say no, not a function. It still technically has domain and range, I suppose. So 1, 4, and -3. Don't need to write 1 again. And its range would be 3, -2, 5, and 7. Okay? And then C here. C is not a function. I draw a horizontal line, it hits twice. So that means that here at 2, if you look right there, 2 has one y value, looks to be about 4.5, and the other y value looks to be about -2.5. So, no, not a function for C. If I was looking at the domain, I would say, well, looks to hit about -1, and looks like it includes -1, so domain for C would be including -1 and shooting off to -infinity, or all real x greater than or equal to -1. And then a range, well, I don't see any reason why any y value shouldn't be able to happen. There's no asymptotes, and looks to me like any y value could come out of this thing, so I would say all real. For this guy here, yeah, function, passes the horizontal line test. Each x value has its own y. And looking at range, or looking at domain, so first, yes, function, domain. I see no reason why we couldn't put in -1,000 and get a number out. No reason why we couldn't put in +1,000 and get a number out. And 0 appears to have a value, so all real. Or you could say -infinity to infinity. Alright, and then range. Range, well, I'm looking at the drawing here, which is always the best way to determine range, and I don't see anything happening below there. So that means that 2 to infinity would be our range, or all real, provided that y is greater than or equal to 2. So for these ones we want to find our domain. Again, if our function has a radical with an x underneath it, then we would say, well, let's set that equal to 0. 4 minus 5x equals 0. So -5x equals -4. So x equals positive 4/5. So that's the number that we can't have happen. So we have to say, or that's the number we can't really go above or below, because we need this to actually always be greater than or equal to 0. Greater than or equal to 0, and then when we divide it by -5 here, we need to switch it. So x needs to be less than or equal to. So all x's, provided that x is less than or equal to positive 4/5, would be our domain. Alright, over here, this x, I don't see any x value we couldn't plug in there, but here we have a value under the domain that would cause issue if it ever equaled 0. So we could say, alright, well, let's set the absolute value of x plus 2 equal to 0. We say x plus 2 equals 0, and x plus 2 equals 0. So we get x equals negative 2, x equals negative 2, no matter what. So all x's, provided that x doesn't equal negative 2, seems to be the only issue we have. Because if it ever equals negative 2, then our domain is 0, or excuse me, our denominator is 0, and we are hosed because we can't divide by 0. Okay, for h of x here, I'm looking at my domain again. X minus 4, no fear, but I can't divide by 0. So I have to set x squared plus 5x minus 36 equal to 0 and solve. Well, this is a quadratic, so the first thing I'm going to try and do is factor. I need I need to know what multiplies to negative 36 but adds to positive 5. So looking over here, I say what multiplies to negative 36 but adds to 5. So I'm going to look at a table here where we say what are the factors of 36? 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And then we would start over from there, and we need those to add to positive 5. Well, it seems to me that 4 and 9 are the only ones that have a difference of 5. We have a difference here of 35, we have a difference here of 16, a difference here of 9, and a difference here of 0. So I'm going to say, well, we got to start with positive 9 and negative 4 then, because that would give me positive 5. So we have x plus 9 and x minus 4 equals 0. So then x equals negative 9, comma 4. So really what that means is x can't equal those numbers then in our domain. So we have all x's provided that x doesn't equal negative 9 or 4. Alright, so we're going to use the graph below, and we're going to find the domain and the range of f. Our domain is going to start here at negative 5 and go here to 5. So we include negative, and go out to 5. Our range is going to start here at what looks like negative 3 and go up here to positive 3 and go nowhere else. So we start at negative 3 and go up to negative 3. But they're all solid dots, so we include them all. We want to list any intercepts. So for B, I've got a y-intercept of 0, 2, and x-intercepts of negative 2, 0, and 2, 0. Right here and here. And a y-intercept there. Okay. For C, f of 1 looks to be 1, comma 3. And then for what values of x does f of x equal negative 3? Well, we've got negative 5 and positive 3. So for D, we would say negative 5 and positive 3. And then E is the range or set of numbers where f of x is less than 0. That's going to be the y value. So this is actually going to have two ranges. We're going to go from negative 5 to negative 2, but not include negative 2 because negative 2 is 0, not less than 0. And then we're going to also start at 2 and go all the way to 3. Oh, excuse me, we'll make it 5 because all those are also less than 0 as well. And we're going to include those. Okay. Okay. Using a graphing utility to graph the function. So we're using our calculator. So I'm plugging in y equals x negative x to the 4th plus 2x cubed plus 4x squared minus 2. And then we hit graph. And our window here, we want our x min to be -5 and our x max to be 5. And we'll do the same for the y min, -5, -5, and hit graph. Oops. Okay, so right now I'm seeing it look like something like this and like that on my screen. So you should be, if you go to window, your x min should be -5, your x max should be 5, and your y min should be -5, y max should be 5. We want to approximate any local max and local min rounded to 2 decimals. So I'm going to find this guy, and then it's hard to tell, but right up there in between those two lines is a local max. So we'll do all three. Alright, so second calc, max, left bound, right bound. So this guy is, I got -0.85, comma, -0.86. So we got that guy. Second calc, let's find a min. And I get 0, -2. So I obviously drew it a little incorrectly, but hopefully you catch the drift. And then we want to try and get our other max. And my other max I get at 2.35, comma 15.55. So there we go. So we want to find where the function is increasing, decreasing, and otherwise. So I'm looking and I'm seeing that we are increasing from here to there, we decrease from there to there, we increase up to that other max, and then we decrease onto infinity. So for decreasing, we do not include negative infinity. Oh, excuse me, we'll start with increasing. I'll change that. Increasing. So we're increasing from negative infinity up to that point there, which would be -0.85. And that includes that point. And then we're also increasing from our other min, which was 0, and including 0, on up to our other max, which was 2.35, and including 2.35. So those are the sets of x values where we're increasing. Then we're decreasing. And we're decreasing in between this point and this point. So we're decreasing here, and then we're decreasing from our max all the way to infinity. So we're going to have two sets there as well. So we're going to decrease from -0.85, including -0.85, down to 0, and include 0. And then we're going to be decreasing from the x value of our other max, 2.35, on down to negative infinity, and on to forever. Okay. Excuse me, this should have been positive infinity, because we're talking about x values. let me start over here. For decreasing, we've got negative 0.85 to 0, and then we have from 2.35 on to infinity, and not including infinity because the x values are getting bigger along that range, and we're talking about in terms of range in x values only, so that would be positive infinity. And notice our whole set goes from negative infinity to infinity, so you're staying with the theme of x values the whole way through. Okay, so we're going to work on this one here. We've got two functions, a and b. We're going to graph the function, list the intercepts, find g of negative 5 and g of negative 2. So first let's graph it. We got 2x plus 1. I'm going to use every other grid line to draw this. So my pen going here. Function a, I'll call that, and function b. So there's 1 up 2 over 1. And we can draw. And come down. And then we got x minus 4, so we go 1, 2, 3, 4. And you go up 4 over 1, 2, 3, 4. And so then we need to erase the side that doesn't work. So first things first, for function b here, everything that's greater than or equal to negative 1. So negative 1, we're right here. So we have a solid dot at negative 1. So we can actually just kind of keep the drawing exactly as it is. But then for this guy here, we're going to have an open dot at negative 1, and everything to the right goes away. Okay. Domain would be all real. All real. As would the range. Our intercepts, we've got a y-intercept at 0, negative 4, and an x-intercept at 4, 0. And they're based off of x minus 4. And then g of negative 5, well, at negative 5, I would plug that into our first function. So we have 2 times negative 5 plus 1, 10 plus 1, which equals negative 9. And then g of negative 2, again, that's the other guy, that's our function a, so 2 times negative 2 plus 1 is negative 4 plus 1, which equals negative 3. And there you go. Alrighty. Okay, so let's do an average rate of change problem. We're going from 3 to x. So really what that means is we're going to subtract f of x and f of 3 and put that over x minus 3. So we end up with 3x squared minus 2x plus 4 minus 3 times 3 squared minus 2 times 3 plus 4. So we end up with 3x squared minus 2x plus 4 minus 21 after you solve for that, which is 3x squared minus 2x minus 21. This guy factors. If you create a chart, you say, alright, I need negative 63 and I need to add to negative 2. 1 and 63, 3 and 21, and then you end up with 7 and 9 and a negative 9 there. So we actually can factor that by saying, alright, 3x minus 9, 3x plus 7. So this simplifies to x minus 3 and 3x plus 7. And that ends up going over our x minus 3. So the x minus 3's can cancel, and our final answer becomes 3x plus 7. Alright. For number 9 here, we've got 2x squared plus 1, and g of x equals 3x minus 2. So we want to find f minus g first. So we get 2x squared plus 1 minus 3x minus 2. That should be a minus. So we get 2x squared plus 1 minus 3x plus 2. So you end up with 2x squared minus 3x plus 3. Okay. And then f times g, we get 2x squared plus 1 times 3x minus 2. So we're going to FOIL. 2x times 3x squared is 6x cubed. 2x squared times negative 2 is minus 4x squared. And 1 times 3x is plus 3x. And 1 times negative 2 is minus 2. And that's actually in correct order. There's no like terms to combine. So that's our answer. Then we have f of x plus h minus f of x. I'm going to erase our first problem here so I have some room to work. So f of x plus h minus f of x is going to be 2 times x plus h squared plus 1 minus 2x squared plus 1. So I get 2 times x squared plus 2xh plus h squared plus 1 minus 2x squared minus 1. Well, the 1's cancel. That's nice to see. And we end up with 2x squared plus 4xh plus 2h squared. And look at that, we have 2x squareds that can cancel. Because you get a minus 2x squared and a plus 2x squared, leaving 2h squared plus 4xh as our final answer. Okay, last but not least, let's consider these two data points. So we want to enter in this data. We're going to go to Stat, Edit, and Enter. If you have anything in L1, you need to go up, hit Clear, and Enter, and you'll clear the whole column. Do the same for L2. Then in L1, we want to go 0, Enter, and all the way through. And enter in all your x values. Even if they repeat, you need to enter them. So I have 0 through 8, and then in L2 I was starting with negative 5. Okay, so as long as your 8 and negative 2 lines up, you should be good to go. Then we want to go to, Stat and over to Calc. So you can press the right arrow button over to Calc, and you go down to linreg ax plus b and hit enter. And you hit enter one more time, and now you get y equals ax plus b. A for this should equal 1.0167, and B should equal negative 8.96. Okay, so you end up with y equals 1.02, just to make it safe, x minus 8.96. All right. And then we want to say y equals, clear. Let's go to graph and hit 9. Oops. Graph, zoom, 9. Zoom, 9. Make sure if you go to y equals, go up to plot 1 and turn it on, and then hit graph, zoom 9, and you'll see your data there. Go back to y equals, and we want to hit vars, And number 5, statistics. Go over to EQ and hit Reg EQ, and hit Graph, and you'll see your line form there. All right. So then we want to do the same exact thing for the other guy. Okay, so for me, after all that, I get y equals 2.02 and x minus 5.33. All right, and when I hit graph, I need to go to y equals clear, vars, vars 5, EQ, graph. And to my eye, looks like our second one is much more linear than our first. So I found the best fit line for each. You can then, given your two equations, go ahead and find f of negative 3. For the first one, I get negative 12.02, and for f of 12, I get 3.28. For our other guy, y equals 2.02 times negative 3 minus 5.33. Let's see, 2.02 times negative 3 minus 5.33. I get negative 8.39. And then for 12, I get 2.02 times 12 minus 5.33 is 18.91. Okay, hope that helps. We will do a review for sure on day 3. Go over any of these that you don't understand, especially the piecewise functions, because I know that was new, and I know it's a lot to ask to have you guys look at the new video and all that. But we will definitely talk about it on day 3, and then we'll have our test on day 1. All right.